In this video, we are going to look at the topic projectile motion. Now do remember, projectile motion is an example of motion in a plane, that is motion in two dimensions, wherein we have a body moving in a curved path like this. Like say when you throw a stone not along the vertical, but at some angle with respect to the vertical, as you can see. What happens is the stone will travel in this kind of a curved path. And the path in which the stone travels while executing projectile motion is called the trajectory. And the body executing projectile motion is what is called a projectile. So here we have a body which is thrown with an initial velocity u at an angle theta with respect to the horizontal, and this body is executing projectile motion. Now this kind of a projectile motion can be looked at in terms of two independent motions, in the sense that this initial velocity u can be resolved into two mutually perpendicular components. So u cos theta is the horizontal component and u sin theta is the vertical component of this velocity u. And it is because of this horizontal component u cos theta that the body is traveling this horizontal distance, and the body is traveling this vertical distance because of the vertical component u sin theta of the initial velocity. So do remember, this horizontal component u cos theta of the velocity has no role whatsoever for the body to travel this vertical distance. Likewise, the vertical component u sin theta has no role whatsoever when it comes to this body traveling the horizontal distance. Now say h is the maximum vertical height traveled by the projectile and r is the horizontal distance that the projectile travels. R is also called the range of the projectile. Now what we want to do is we want to find the expression for h, we want to find the expression for r, we also want to find the expression for the time that the projectile takes to reach this point, and we also want to find the equation for the kind of path that the projectile describes. Before we proceed any further, let us give a look at these equations of motion, and I'm presuming that you are very familiar with these equations. The first equation is v is u plus at, that is the final velocity is equal to initial velocity plus acceleration into time. Second velocity giving us displacement, s is equal to ut plus half at squared. The third equation is v squared is u squared plus 2as. And the fourth equation, which says distance is equal to speed into time, is actually, this equation actually comes from the second equation itself. This is a case when the acceleration is 0. So when the acceleration becomes 0, we have displacement is, or distance is, speed into time. So it is these four equations of motion that we are going to need to do the derivations. So the first thing that we want to find is the equation of the trajectory, or the equation of the path of the projectile. So we consider any random time t after the motion of the projectile starts. In this random time t, the body would have traveled a certain vertical distance and a certain horizontal distance. It could be wherever, it could be here, it could be here, it could be here, it could be here, wherever. So the vertical displacement of the body after time t is given by this equation, s is ut plus half of at squared. Now let us consider the random vertical distance at time t to be y. So y is u sin theta into t. U sin theta, don't forget, is the vertical component of the velocity. And it is only because of the vertical component of velocity that the body travels some vertical distance. The horizontal component of velocity has no role to play whatsoever for the body to move in the vertical direction, remember. So since we are considering vertical displacement, the vertical displacement y at any random time t is given by u sin theta into t plus half into, what is the acceleration? Acceleration is g, that is the acceleration due to gravity. And why the minus sign? Because the body is traveling in the upward direction, the projectile is traveling in the upward direction, and the acceleration due to gravity acts vertically downward. So since the motion of the body and the acceleration due to gravity, they are opposite to each other. So therefore we have this minus sign. So minus g into t squared, because of which we get y is u sine theta into t minus half gt squared. Let this be our equation number 1. Likewise now, the horizontal displacement after the same time t is given by x, which is u cos theta into t. U cos theta is the horizontal component of velocity. So therefore t from this equation is equal to x upon u cos theta. This is our equation number 2. Now substituting the value of t from equation 2 in equation 1, we get y is equal to u sine theta into this t is x upon u cos theta minus half g t squared is x upon u cos theta whole squared. So finally we get y is equal to tan theta x minus half g upon u squared cos squared theta into x squared. As written over here, you can see that this equation 3 is quadratic in x and linear in y. So any equation of this kind where one of the variables is quadratic and the other variable is linear is the equation of a parabola. So therefore the path of the projectile is parabolic, which means this path is parabolic in nature, as you can see in the picture 2. Now I don't know whether you've done something called conic sections in mathematics or not, but do remember any equation of this kind that you see where one of the variables is quadratic and the other variable is linear, that is raised to the power 1. Okay, any equation of this kind that you see is the equation of a parabola. Since our equation here is of this kind, where x is quadratic and y is linear, so therefore this is the equation of a parabola, remember. And a parabola looks exactly like this. It's a very symmetric picture, such that if you cut it here at the center, this side will overlap with this side. So they are completely symmetric. Now let us try to find out what is the total time taken by the projectile to reach from point O to point M, which is also called the time of flight of the projectile. Now in order to do that, what we will do is we will first find the time taken by the projectile to reach from O to P. Now since we've already discussed that a parabola is completely symmetric, therefore the time taken by the projectile to reach from O to P will be the same as the time taken by the projectile to reach from P to M. Also, at the maximum height or at point P over here, the vertical velocity of the projectile is 0 because it's not going to go any further in the upward direction. Therefore, if t be the time taken by the projectile to reach the highest point P, then we get 0 is equal to u sine theta plus minus g into t. Where do we get this from? We get this from the first equation of motion, which is v is u plus at. At the maximum height, we've already discussed v is 0. The final velocity at the maximum height is 0. The initial velocity, we are considering vertical motion, so therefore the initial velocity is u sine theta, plus the acceleration is g with a negative sign because the vertical motion and the acceleration due to gravity are opposite in direction, and t, the time taken to reach the maximum height. So therefore t is u sine theta divided by g. Now since we've already seen that the projectile moves in a parabolic path, it takes the same time t to reach point M from P as it takes to reach point P from O. So therefore the total time of flight of the projectile is given by a capital T, which is equal to 2 into this time, equal to 2u sine theta by g. So this is the time the projectile takes to reach point M from point O. That is the total time of flight. Thirdly, we want to find the maximum height reached by the projectile. We are calling that maximum height capital H. So the maximum height of the projectile is given by this equation. And since we are considering vertical motion, so therefore the final vertical velocity is 0. So therefore 0 squared is equal to the initial vertical velocity is u sine theta. So the square of that is this much, plus 2 into the acceleration with a minus sign into the vertical height h, or 2gh is u squared sine squared theta, and thereby we get h is equal to u squared sine squared theta upon 2g. So this is the expression for the maximum vertical height reached by the projectile. And finally, we want to get an expression for the range of the projectile. That is the horizontal distance covered by the projectile. Now, do remember, when we consider motion along the horizontal direction, there is no acceleration of any kind acting in the horizontal direction. Whatever acceleration is acting as the body moves in this curved path, that acceleration is only acceleration due to gravity, which is acting in the vertically downward direction. So there is no acceleration whatsoever in the horizontal direction, remember. Therefore, the range of the projectile is given by distance is speed into time, or distance is r, which is u cos theta. This initial horizontal velocity is u cos theta, into time is the total time of flight, since the projectile takes time capital T to move from O to M, that is the time of flight. Therefore, r is equal to u cos theta into the time of flight is 2u sine theta upon g, and thereby we get r is 2u squared sine theta into cos theta upon g, which can be rewritten as r is equal to u squared sine 2 theta upon g. Now again, I don't know whether you've done this in your trigonometry or not, but you will learn, if you haven't, that sine 2 theta is equal to 2 sine theta into cos theta. So therefore, instead of 2 sine theta cos theta, we rather write sine 2 theta. And therefore, r is equal to u squared sine 2 theta upon g, which gives us the horizontal distance or the range of the projectile. So it is these four equations that we derived with regard to projectile motion. Now, you all need to learn to derive all of these equations. And if you can remember the values of equation 2, 3 and 4 over here, it might be helpful for you all, because you will also get numericals to solve based on these equations. Even if you don't remember the values, do learn how to derive these equations.